Yeah, I've been doing a huge amount of
Okay,
remote.
good morning, everybody. Welcome to Practical in the Time of Pandemic, which is the 9:50 session. We're running a minute or two late based on the panel discussion overrunning, so apologies for that. Hope that hasn't thrown you this morning. As I say, this is going to be Practical in the Time of Pandemic with Joe Rowing from Exeter Maths School. If that's not the session you were looking for and you are attending live, then you perhaps need to hop off this call and just go back to your set of links and try once again. If you are in the right place, stay put, that's great. There is a Q&A facility that will support the session. You're welcome to contribute comments, thoughts, questions, which will either be picked up in the chat or Joe will address them throughout or at the end of the event. If you're watching this on catch up, then great to have you with us as well. You can remember, pause, rewind, go back through parts again. And in this stream, there are a number of sessions that support this same subject that you can access later. So it's really great to have Joe with us, as I say, from Exeter Maths School, talking about Practical in the Time of Pandemic. Welcome, Joe.
Thanks, Anthony. Hi. My quick bit of background, I'm principally a physicist, but I'm going to try and aim for kind of a wider, a wider church, as it were. So looking at anything practical in this kind of really unusual time. Obviously, some of the examples I'm going to use will be from my own subject, because that's the subject I know best, but we'll see as we go. Okay, so hopefully you can see my screen. I'm going to change the camera view a little bit. And as we go through this, behind me you should see essentially the statement of the requirement for us in terms of required practicals for the next year. So the kind of context or sort of going forward from this point is that actually our requirement to do practicals in the lab is reduced, or at least that pressure from say exam boards and the like. I would encourage you to resist, obviously, as best I can, the temptation to then wind down the quantity of practical kind of provision, because it's such an important part of all of our subjects. Before I go any further with it, I ought to point you, if you are not already familiar, in the direction of CLEAPS. If you don't use this kind of service in your particular settings, then I believe that all of the coronavirus elements of it are free, free to access. And this is the school science safety organisation's kind of guidance on what you can and can't do. And so this is the yardstick. If you're not familiar, this is the yardstick by which you should kind of sense check the things that you intend to do with students, either at home or in school. So I think probably the first place I want to sort of look at is the things that you can still do and the sorts of practicals that you might enjoy and the sorts of things that you might want to do yourselves or get the students to do. So I'm actually going to switch over to a different camera and physically run around a little bit, because I want to show you what I've got set up. So I've done a whole load of kind of practical physics, practical things from home where I am now. And this thing here that you can see on the main screen, if I stick my hand in the way, I can wave at you. This is a little light box. It's 60 centimeters by 60 centimeters, and it's, if you like, my base of operations for just about all of the kind of remote support that I've been doing for students and otherwise. And actually, it's a total mess because it's prepped up for an electromagnetism session that I'm doing about 10 minutes after this. But very quickly, because it amused me, I'd forgotten, you tend to concentrate on your own subjects a little bit. You tend to forget about all the fun things that you can do, like, for example, a little bit of chromatography here. I happened to drop some of my little sanitizer gel, little alcohol-based sanitizer gel, on some of the permanent marker that I have lying around, and it just sort of illustrated to me in an amusing fashion this morning exactly the kind of thing that I'm going to try to convince you of. So there's a couple of bits of chromatography going on. Contrast's a little high on my camera, but there you go. A few little bits of chromatography going on, just to illustrate the sorts of things that you can still do. You can still do a huge amount of practical. So let me show you. I'm going to move over there, so I'll disappear from the screen, and I'll show you just a couple of the things that I've been up to. Okay, so one of the things that's been most entertaining, I think, to do as we've been going along, are the little kind of project type kind of investigations, because you can still do a lot of these things really quite easily and cheaply. So this here you can probably see from the top is a water bottle, and it's got something in it. This is actually a little Cartesian diver, and there's a brilliant Key Stage 3, Key Stage 4 or primary school investigation in here. This one here is actually made of a little pipette with a little mass on it, and as I squeeze this thing, the density of it increases and it sinks. And as I release, the density decreases in it and it rises. And it's a really lovely kind of hands-on way of learning a little bit, in this case, about density. And this kind of, I sort of wanted to encourage you to take this kind of ethos of play and really run with it in your subjects, because you can go a really, really long way with just a bit of play and a bit of creativity. So this here is a thing called a shaker gen. This is a little neodymium magnet and a little bit of wire that I've recovered from a dead speaker. Oops. And a huge. This magnet is pretty strong, but if I pop my magnet inside there like that, as I shake my magnet back and forth, I'm actually generating current. And I've got a little thing which, if I can get the camera angle right, which lights up, which is again really nice. In this case, it would be electromagnetism, Key Stage 4 kind of topic, or even A level. So that's fun. You can do a lot of playing. These things. This is actually a little kind of aircraft, believe it or not. If you spin it backwards, you can take account of Bernoulli, of the Magnus effect, and this little thing can sort of fly along. And the list kind of goes on and on. So lots and lots of little fun kind of activities you can kind of play with in order to try and illustrate the points as you go along. Now, they are incredibly subject specific. I'm going to flick back to me again. I'm actually going to go back to my website, because some of these things are really difficult to know kind of when to do and where. Particularly, I have a lot of non-specialists in my subject that we support. You're really, really welcome to drop me a line, or you are probably already working with Institute Physics in some way. I'm an Institute Physics coach. You're welcome to drop me a line. I'll put all my contact details in this at some point if you need a bit of a hand with what to do for that particular topic. But let me show you some of the sort of other things that are going on and some of the kind of simulations that you can use. Now, you've got to be really careful with simulations. They are often of a low or secondary kind of quality, but the really good ones can actually improve a lot of the experience. So I've shown you my little light box and things, because actually what a lot of us are going to end up doing, I think, next year is probably recording videos of us doing some of the practicals, or recording some of the element of it. And then a lot of us are probably going to end up with the students doing something like these sims. I'm actually going to dive into an earth science one, because earth science is often underrepresented. So I'm going to dive in here and I'm going to look at a glacier sim. I mean, actually, no, let's have a look at something else, one I haven't seen for a million years. Let's have a look at something like under pressure. Okay, so this is a nice little one. We've just had a pressure demo of my Cartesian diver. Most of these simulations are in HTML5, so these are cross-platform. You can use them on a mobile device or anything else. So we don't have as many of the worries about students being able to access this as we might do, because the majority of students have got some mechanism for accessing this, be it smartphones or some sort of tablet in the home, or, you know, there's usually something in there, some electronic device that a student could use. And these run, you know, equally well across all of them. And I can change things like density. In this particular case, this is trying to show you that if I displace some water, then the other one is you're going to end up with some kind of hydraulic action. And this is basically modeling a little hydraulic piston, or the fact that the shape of the container doesn't matter to the height of the water and those kind of things. The content less important in this particular case than how you can use it and how these might be able to support your learning, okay, or rather your students' learning. It's a lot of fun to be had with these things. They're really quite neat. So let me get rid of that one. So those PHET, it's backed by the University of Colorado. They're really, really good quality animations. I suggest that you look at those. They're really nice. There's a huge number of other resources out there for all kind of things. So the whole of the Royal Society have been working quite hard. They've got a whole load of videos and a whole load of experiments in the background. The RI have been working really hard with a lot of things in the background. So do have a look at these. A lot of the big organizations have been putting a lot of work into kind of supporting this kind of doing stuff, but remotely, because it's so engaging and so entertaining and adds so much to our learning. In my subject, there is a little substitute for the Marvin and Milo kind of cards. We give these out all the time, but do have a look at the Spark website or the Institute of Physics website, and you'll see loads, and my internet is clearly playing up. We see loads and loads of good examples of practicals that you can do at home safely with no kind of requirement for specialist equipment. Everything from, you know, I don't know, mucking about with a magic blue. Let's see if this one will work. So no, it won't. That's annoying. This is my browser. I've got I'm right out in the middle of the countryside where I am, and it's a little bit challenging. So Coronavirus Hub at the ASE. Again, I feel like I need to share and show you some of these before I dive into the next kind of nifty activity. Loads of good things here, loads of really useful bits of support. Now, two things that are very technology based that I want to show and to illustrate. The first one of these is very mathematical. If your subject isn't mathematical, please don't switch off. Kind of just bear with me for the first moment, because you'll see how incredibly useful I think this can be. So let me turn on, hopefully my curious. Okay. Slight technical hitch. 1 second. Excellent. Right, so this is a program called GeoGebra. Right, it's strictly, originally this is built for mathematical modeling, so you know, mathematical graphing. There is essentially nothing-ish in science, in you know, computer science, earth sciences, biology, chemistry, physics, that isn't in some way, doesn't in some way have a mathematical model behind it. So my favorite example of this is probably something like waves, and a wave is just for example, a sine wave, sine of x, and I'm going to have cos of x in there as well. So this would be the principle of, I'm sort of working towards a principle called superposition. And I'm going to try and show you how easy it is to do that. I've got a function f, which is my sine. I've got a function g, which is my cos. And actually, GeoGebra is really clever, because if I ask it to add f and g together, then it does exactly that, and I get the kind of resultant superposition of those two. So that's incredibly mathematical, I suppose, but there are loads and loads of others that you can play with quite neatly. Here is a version. I'm just going to make sure this is actually fitting on your screen. So here's a version that I cooked up whilst watching a film. The film was Jump. No, it wasn't. It was Jump. Oh, I've forgotten the name of it now. That's embarrassing. It's a great film with it's a film with Dwayne Johnson in. Somebody's bound to put it in the comments. I think it might be some skyscraper remake. Anyway, he does this lovely jump from a tower into a skyscraper, and I've built a little simulation here in order to see if, with some starting parameters, he can make the jump. So really powerful, really nice. I've done all sorts of things in this, from the game of life and looking at population explosions and population distributions, to looking at, you know, modeling kind of clock reactions and those kind of things, looking at pH kind of scales. Anything you can model mathematically in any way, looking at, you know, reactions, the before and afterwards, all that kind of stuff. Anything you can model mathematically, you can probably do in here really nicely. And better if you go to the GeoGebra website, which is just GeoGebra.com. If I turn this back off, I think I've got it up here. Let's go to here. If you go to the GeoGebra website, there are hundreds and hundreds of resources in all sorts of things, all sorts of subjects. There are 3D versions. I don't have time to go into it now particularly, but there are even kind of versions of this which allow you to tie into VR and do some, I might have time to look at this in a minute, tie into VR and kind of look at a blend, AR, augmented reality, sorry, so you can overlay a mathematical kind of or a model over the real thing if you're able to do that. Okay, I've got a little course that's in here. I'll share this in amongst all the links. If you want to get to grips with GeoGebra, you can see the sorts of things that you can do right the way from the ones that I've shown you to, these are obviously physics based because I generally talk about this for physics. So here's a damped oscillation of a pendulum, just to show you the sorts of things that you can model quite effectively and you can build up to. Yeah. So there's a little bit of polarization perhaps, so the only thing I can immediately think of is probably a couple of biological examples or a couple of microscopy examples, and so you can sort of play around and see how different filters affect different kind of polarizations, those kind of things. Okay, really, really good resource, really neat. Okay. The next resource I've got for you is this thing. If you don't have Firefox, it's absolutely awesome. I see you are still, that's annoying. You're still seeing that page. Let me show you this. Okay, apologies. So I was showing some of these resources here. These are the chemistry resources. Apologies for that. These chemistry resources here in GeoGebra, awesome. I have got a little course I will share, sort of how to build up to building some of these things. I will share that with you in due course. But here's a CH4 molecule that you can spin around. If you want to look at this in 3D, you can do all that sort of stuff. Really, really nice bit of kit. So I was going on to Firefox. If you don't have this yet, then I honestly think you're missing a trick. It's free. It's on Google Play in the App Store. This is probably the ace in the hole for your students and for you doing practical physics or practical chemistry or anything in the home or in the lab or all sorts of things. Please try that again. That's odd. So loads and loads of really nice stuff here. I'm actually going to switch back across to my other camera and I'm going to show you a couple of things that this app can do. So let me switch like this. Okay, so I'm going to dive back over there. Okay, so this is the app running live on my mobile phone. I need to just get the angle of this right a little bit so you can see it without too many lights reflected. Okay, and I've got a whole load of I've got the ability to use a whole load of the different aspects of different bits of sensors. So for example, I'm going to start with the light sensor because actually the light sensor is really neat and it will give me a recording of the illuminance on the little light sensor, which in this case you can see on my GeoGebra. This is actually my GeoGebra phone. I'm that keen on it. The light sensor is just up here, so if I cover that up, then you can see that that is graphing the light. And you can do all sorts of stuff with this. I could, for example, model the way we detect exoplanets by passing an object between the light source and the phone, and you can see that we can get a periodic dipping of the light intensity. I could pop this in on top of I could pop this on top of say a clock reaction and use it to time a clock reaction. I could stick this down next to my biological samples, grow a couple of different things, and look at the way, for example, light level affects germination. I could, or anything that might require light. Now, actually, whilst I'm showing this, I really should I'll let that run for just a second. Then I'm going to pause it. I'm going to show you some of the neat things it does. So in the little menu here, I've got an export data or share screenshot or a timed run, or even allow remote access. If I'm having some network troubles here, so I'm not going to risk this. I was planning to, but I'm not going to. If I tick the allow remote access, I can actually log in. My phone will become a little host. I can actually log into this then and display this screen on my computer. So if I'm trying to do an experiment and cast it across something like Teams here, I can show a much larger thing without having to wave my mobile phone around. Or if I'm doing this in a classroom where we're trying to demonstrate a practical and I want to get some data up onto the board, because remember, certainly in the first iteration of being back, some of us are experiencing this already a little bit, but we can't get closer than a couple of meters away from the students by regulation. So it's very hard for us to gather, we can't do that demo thing of gathering everybody around. So we need to work around it. My solution is going to be, as you might guess, taking my little light box in. So even when I'm in the classroom, I shall have the light box. I shall have a couple of cameras here set up, and I will then use stuff like this in order to show the output, show the experiment. So I can also export the data, and you can see I can export it to Excel or as a CSV, so that means comma separated values. So that will allow me to put it into, if you're a computer scientist, you can take data straight from here, straight into Python, and you can process it in Python or R or any of the other languages. Or, if you just want to drag and drop it into Word or whatever, you can do that. So let me show you a couple of the other lovely things that it will do. So this is now getting raw data from my magnetometer. Okay, so this is the magnetic field sensor. So to take an earth science example, you can see that as I change the inclination of my phone, this is changing the measurement of the inclination. You can see that bottom graph is going up and down as I rock this back and forwards. So you can see that as I align this with the dip of the magnetic field, and if that doesn't make any sense to us, then look it up. It's a really fascinating thing. As I align this with the dip of the magnetic field, then my sensor is changing. So a lovely thing I did with this the other day was my friend in Arizona and I compared the magnetic field and the angle at which that magnetic field meets the Earth, and we ended up building more or less an entire lesson over it, which was lovely for a few students. Things like pressure's really nice. If you pop the pressure on, share this to the board, pop the whole phone into a jar or into a bottle, and then as you squeeze on the bottle, you'll see the pressure change, and you can do a kind of measurement of pressure and the like. Let's do some other bits and pieces. Then there's all sorts of things, Doppler effect. This thing is right. So this is now chirping, as you may be able to hear, and it's listening for the echo of that chirp, and it's using the time between the chirp from the speaker, which actually on this one is at the side here. So this is chirping. It will be the chirp will be reflecting off the wall of my box, and then it'll be being picked up by the mic, and so it's giving me a measurement of how far away that is. And it's actually, in this particular view, showing me all of the different echoes that are coming back. So if I switch it to proper echolocation, you can see, hopefully reasonably clearly, that it reckons I'm about 30 centimeters. Look at the peaks are mostly about 30 centimeters away from the wall, which would be bang on correct. Okay, so a bit of echolocation, really nice to be able to do that, especially if you're talking about it later on. And then just to show you a couple of the other things before I switch to my next kind of bit. This is the applause meter, and it'll give you, a score based on the loudness and the duration of the applause. So if you are doing some, trying to do some daft little game, you can actually have a kind of competitive element to it, and have a proper little applause meter. Loads and loads and loads of other things, lots of timers, things like an acoustic stopwatch. I'm getting a bit carried away here now, but for example, my voice is probably. So hopefully you could see that as I was clicking my fingers, then it was giving me a time between clicks. Okay, so if you need to time an event, that's brilliant. You can, for example, drop a bouncing ball and see that and time the different bounces, all sorts of things. Loads and loads and loads and loads of things. Any smartphone will do these kind of things. Yeah, I'm going to probably stop there. Really, really good. Firefox, PHOX. Amazing little app. Okay. So I'm going to come back over here. I'm really conscious of the fact that I'm battering through these things. It's 'cause I'm looking at the clock and trying to make sure I get a moment or two for questions at the end. And so there's a few things that I want to kind of get even more animated about, I suppose, really. Right. So hopefully, I've thrown 40 minutes, or in this case about 20 minutes is too short really to take you step by step through all sorts of through everything, but hopefully I've kind of encouraging you to be a little bit creative about it. I mean, I've distracted myself. I'm terrible for this. I picked up this fidget spinner and remembered one of the many examples I was going to show. If you use the light sensor on Firefox and a fidget spinner, you can actually spin this between your mobile phone and a light source, and it'll give you the rate at which this thing is spinning. There must be some really cool things that we can do with that. Certainly are in my subject. There's you can have a lot of fun with it. Okay. Now, I'm going to be, I don't know, I was accused of being controversial when I said this the other day. I think there are a number of things that we can do where we are working remotely in particular. So if we're in this situation that a lot of us are in now of having a lot of students distributed around. I mean, Exeter Math School we take from the whole of the southwest. We only have a few students. We're really small at the school. We've got people dotted right the way around the 4 counties, and so that there are a couple of sort of interesting things you can do there that actually are to your advantage. So, for example, I've got some students down about as far south as you can be in that range, and I've got some about as far north. This means that if I get them to take say a 30 centimetre ruler outside at midday and measure the length of the shadow, I could come up with, or rather I can get them to share their data and they can come up with a measurement for the radius of the Earth. If I want to do a little bit of biological or geological kind of comparative work, then you've already got people distributed around in different locations, in different habitats, in different environments, and you can send everybody out into the local field, just say go out, find a bit of grass, pace out this kind of size, take a survey of what you can find, let's compare it, let's talk about it, let's talk about where you are, let's look at a back garden versus a bit of grass outside of a block of flats, or you can really localize and really engage, I guess, by taking advantage of the situation a little bit. And I just jotted down a few things that I could think of straight away. Everything from population densities of people, of creatures, looking at traffic kind of surveys. If you'd been doing a bit of a survey of things over the last kind of few weeks, you would have seen that the car traffic is come up very sharply, and the number of people cycling has kind of reached the peak and is tailing off a little bit as we all start to do a little bit longer journeys and head back to work. The number of people taking public transport, if you happen to have people that are near stations and they can take a snap survey at say 10 o'clock just before the train goes or something, you know, the number of people taking those has increased, but not as rapidly as you might have predicted. And you can tie a lot of this into current events, and we shouldn't be afraid of doing that, of tying, you know, all of this kind of context that we've got into the science of it. Okay, loads of astronomy. There's really clear skies. You can do some really nice stuff with that. Lots of weather. Again, you can have lots of comparative weather data. If you were to say arbitrarily measure wind speed in some, even if it's a qualitative way, then you can come up with a really good distribution across even a town, for example. Now I'm going to, there's loads of ideas there. I've thrown a whole load of things out. I'm going to dive into one of them a little bit more deeply, just to show you the kind of thing, or the kind of thing that I've done very successfully, in this case a number of times in the past, which has actually made it a little bit easier for me to try and do some remote physics. So let me switch across to my little background here. All right. So I'm actually going to just show you whereabouts my that's frustrating. I have a really weird issue here that sometimes I know I'm on a live stream here and I know it's working, and for some reason it's telling me there's no internet on my browser. It's incredibly infuriating. Come on.
Happens to us all, Joe.
Yeah, it's really it's that thing. I thought, right, there's one thing I'll do live. Okay, I was going to show you a map of the school and show you the context locally, but I can't. So again, I'm a huge fan of mobile phones, mobile devices. If you know, Firefox gives you all of the data that these things churn out. You can use that to infinite advantage. Here is a version that I've been doing for maybe, I don't know, as long as mobile phones have been around, just to, I don't know, hopefully make you go, there's something I can leverage in my subject with my students. So this here is is a website called Cell Mapper. This shows you where the mobile phone masts are. This is kind of like the end bit. I've already got this one loaded, so I've got it up. One of the things that we have been doing with students, I really like doing, there's a bit of my course at GCSE where we have to talk about different parts of the electromagnetic spectrum. Microwave radiation, which is the thing that your phones run on, or your phones use to communicate, I should say. I should be more precise in my language. That microwave radiation is part of that electromagnetic spectrum. Obviously, we can't see it or anything, but you can detect it. So using the signal strength of your mobile phone and just walking around, literally walk around the house, around the outside of your house, and jot down where the signal strength is strongest and where it's weakest. Jot down, historically we used to use where the sun rises in order that we've always got some kind of geographical orientation of that map. Then collect all that information together and you can work out, using a little bit of trig, where the mobile phone masts are. The version that I was going to show you is I've actually got a map of my school divided into grids, and we send the students off, they have a wander about the school, they jot down which bit of the school they've got, for example, 5 bars in, which they've got kind of 3 bars in and no signal at all. And then by looking at that, you can work out where around the school the nearest mast is, and along the way, from my subject, I can talk about diffraction and interference, and it pulls together a whole load of different aspects. We can then talk about, well, why don't you just build a mast right on top of the school? Surely you've got a load of captive students, and what's the problem with that? Well, again, it comes down to all sorts of things, and you can pull in the politics and the finance and the difficulty of arranging to actually rent the space, and then you can pull in the kind of health aspects, and it acts as a kind of a locus, as a focus, as a leverage point for a really interesting discussion. And and you've set this hook by using something which is so familiar to divine some information which is quite abstract. This is the end result. We usually, having worked it out, will then look it up. So you can see for Exeter, actually it's pretty difficult. You tend to get pretty good signal just about everywhere. What's really interesting is you can then go a little bit further if you really want to, and you can compare different providers. So you can compare the location of EE or Vodafone or whatever, and you can actually kind of work out the location of the different masts that the different providers are using if you want to. So you can really go a long way from a really small simple bit of data. Now I've got a couple of other bits and pieces, but I'm really conscious that I haven't answered any questions or haven't looked at any of those sorts of things. So I'm just going to take a pause and just have a look and see if anything's come in, and to really, really encourage you. Now, I know there's about a 10-15 second delay on this, so I will amble through and witter on about some bits and pieces. But please, if you've got any questions, chuck them in. There's loads of things. If you think, oh, but this doesn't apply to me, how would you do this for that subject? Please throw that in at me. I'm more than happy to try and think on my feet and come up with some examples of different bits and pieces. I'm going to take the opportunity whilst I'm looking at that and whilst I'm waiting for a moment to show you a mathematical example. These things here are really interesting. Solids of constant width. Right? So these are really snazzy solids of constant width. They're been specially made by a maths company, Maths Gear, and they're really interesting because if you roll these along, they're actually a constant diameter, and so if you put a ruler across the top of a couple of these, that ruler will roll really evenly. And you think that's weird, that's interesting, I bet that's got no apparent use whatsoever. Well, actually, there's a really, really neat example in coins. Coins have to be the same, have to have a constant diameter. Now, I'll leave you to think about why for a second, but coins have to have a constant diameter. The fact that we can do that, we can give them a constant diameter and give them a unique shape, is a really interesting thing. There's a little investigation there for students, and the answer to why we need different a constant diameter is, of course, vending machines, because you've got to make it such that it's independent of orientation. Okay, let's have a look at those questions. Wow. So I'm either talking to myself, or I've bamboozled you entirely, or your head is reeling, all of which are relatively normal when I get going on a mad topic, because I've got very few, none in fact, that count as questions, I think. Let me just dive in, see if any have been published. Yeah, not really. Okay.
Some lovely comments, Joe, but no, I think you've addressed everything people were obviously thinking about.
Okay. If there are other bits that you want me to kind of elaborate on, then please kind of shout. I think it's really, really important. There's going to be really, really tempting for us to step back from kind of practicals. It's going to be difficult for us, particularly as we come back in the new year, to run practical science or practical activities in the same way. There are ways that you can get around it with changing the game a little bit. There's lots of timetabling things that you can do to allow you to leave your practical equipment to one side for 72 hours. But if you can exploit the things that the students are already handling, and I know this is going to break the rules at a lot of places, but most of your students will have some kind of a mobile device, and the few that don't, you can get a device to them from somewhere. There's bound to be a load of staff, a load of teachers who, like me, have got their previous smartphone from their contract kicking about. They might be able to lend to you. Gather all of that. You've got then something which not only can they access the internet, they can access whatever, really neatly. Your IT department should be able to give you a restricted Wi-Fi if you want to use that. so that you can allow the students to access these things. I'm probably going to cause all sorts of people all sorts of headaches by saying this kind of thing, and I apologise if you're the person to whom I'm giving a headache, but it's time to think differently and to kind of get out of the old way of perhaps viewing some of this stuff and realising we can take it to our advantage. It doesn't have to be that. If you are at the sort of place where that's never going to fly, then here's a little example of a thing that you might, an alternative kind of route you might think about. This cost me £2 from eBay. This is an acceleration data logger. It plugs in and it gives me a text file which I can just drag and drop into Excel of data logging the acceleration. I press a little button on it once to start the thing from logging, and when it started it's got a little LED that's flashing, and then I can do whatever experiment I want, then press the thing afterwards and it stopped flashing. So if I'm doing motion, if I'm doing whatever, I can give this to some students. They can run around at home, or they can run around in the lab in the school at a social kind of appropriate social distance, and they can record some of this. You can then plug it in and share it with them. I don't need to have hundreds of these, because if I am going to use this kind of thing, I can record, I can share the data from this. I can ask the students to look at it. I can put it up on the board. We can collectively look at it. We can spread it more widely. And just because I can't resist it, and I've noticed that I've got a couple of minutes, I'm going to show you just two experiments that they're blatantly me leveraging in some weird physics experiments, but I just can't resist it because they're just too cool not to do this. So I'm actually going to go back over to my little setup and show you these. And then what I suppose I should do is, if anybody wants to see the setup I've been using to do all this, you're very welcome. I'll show you that quite happily. Right. Just a curio, this is a thing called a rattleback. I hadn't managed to work out how to get this into lessons for years and years, but I worked out the other day, and they're really cool. You spin them one direction, they spin freely. You spin them the other direction and they'll stop spinning, and if it's on a little bit smoother surface, it'll actually spin back in the other direction. Let's try that again. So spin freely, stop, spin in the other direction, and you can make them really easily. This is a bent spoon. This does exactly the same thing. It will spin easily in one direction, or if I start to oscillate it, it will start to spin a little bit in that direction. It took me ages to work out how to get these into a thing, but they're just really, really fascinating. And actually, the thing that made me finally put the hours in to work out how to use it is that some of the students were so kind of mystified that I thought, hang on, why am I not exploiting that? Why am I not using that hook to try and drive, in this case, a friction experiment? Really neat. A couple of magnets. These are a couple of fridge magnets, an electric motor, a couple of fridge magnets. We're firmly in the realm of, here's a toy to talk about to allow you to do some kind of investigative science. I'm probably going to have to show you this on I don't know, this camera. Hopefully you can see the top. I've just got a bit of wire from top to bottom, and I've got a little electric motor which will sit there and spin, and I can explain the science of it if you like. Or I could start saying to you, why don't you change the magnets, change the polarity, tell me about it, tell me what happens. Right, and with my last kind of remaining moment or so, I'm just going to show you my little setup, because it's always good to see behind the scenes, I think. Because if you are in a situation, we are bound to be in a situation where we will be locked down again entirely. I think this is probably worth sharing. So I've been doing loads and loads, and I'm moving you around a bit now, and my green screen, which is obviously you can't see, which is behind where I have been sat, is still showing you a bit of grain chill set. But this is my kind of setup here. I have a couple of these cameras. They're really nice. So in terms of trying to do live demonstrations remotely, this thing here is a 60 by 60 light box, because it turns out lighting is one of the most key things to trying to show practicals. It's really difficult to kind of show stuff remotely if you haven't got this kind of setup. and then I've got, you know, the tools of my trade around. But I would expect, you know, that most departments, most places could stretch to, there's a webcam up there, there's a webcam for the side view. We've got one of these set up in the school to allow us to support students who won't be able to come in, students who are going to miss practical sessions. So our required practical for some students may have to be, because of their health or whatever, may have to be them seeing us talking through it. So because you've kind of got that one hit, there's side camera, top camera, you can have multiple views. We're going to record it so that they can go back and revisit it, and we'll take a little bit of time as we're explaining it to explain some of the misconceptions and to go through it step by step. You'll see loads of paper in the background. Another top tip, if you're going to write on anything, Crayola or other pens are available, and a bit of white paper, and then the exposure of that thing there turned up a little bit. Anyway, that is my time. I've really enjoyed showing you some of the bits and pieces and basically ranting at you and trying to compress kind of 4 hours worth of hopefully interesting stuff down into 40 minutes. My kind of Twitter handle, for want of a better word, is up there. You're very welcome to get in contact with me there. My email address, I'm sure, will be shared, and I will share all the links that I've been showing you in this. Thank you enormously. Thank you very much indeed, and thank you, Anthony, for being behind the scenes and doing the broadcasting and keeping an eye on the questions and those kind of things.
No problem. Joe, thank you so much. That was sincerely fascinating. I think I, like a lot of people, probably have started to make a list of things to go away and look into based on your session, and even actually at Key Stage 1 and 2, which is my home, there's so many things there that were really relevant and fascinating. I was starting to tag people into your session throughout that just to say, you have to come over and watch this. I can see
thank you, very kind.
Some holiday task to go through those. But thank you very much. Really appreciate you making the time to be part of the event and delivering that, because that was wonderful. Thank you very much.
Not at all. It's actually worth saying, if I may tag, I can't resist leveraging one last bit in, and I know we're over time. Key Stage 5, Key Stage 4 people, Key Stage 3 people, go and talk to the primary school guys, because the activities that they've been using in their sciences and in their practicals for years and years and years are just as valid for Key Stage 5, even degree level science. So go and talk to them, because they will have a load of ideas that you've never thought of. Play-Doh electric circuits, for example, and all sorts of things. Go and talk to them if you haven't already, because they will have a whole load of things that you can safely do, your students can safely do, and that you hitherto might have ignored because it isn't the proper kit, but it's the science that we're interested in, not the kind of official equipment. So anyway, I will shut up now. Thank you very much indeed. See you all later.
Not at all. Brilliant. So if you're watching live, you've still got about 5 minutes till the next session starts to have a quick comfort break and grab a cup of tea. If you're watching this on catch up, then as I said before, there are a lot of sessions that support, and I don't think anything that covers the same ground that Joe has, but things that are definitely worth your time to have a look in. But thanks for attending. Bye bye.